Hey everyone, this is part 4 of my anti-tutorial series, and today I have actually a to-do list of what I want to do, and I want to implement the linked list for the physics handler, a register function with which we can register the objects with the physics handler, a game state for the game controller, and that's what I'm aiming for basically today. So if we go to the game state problem, I've already got query performance counter listed here. Should probably do that as well. So what we want to do is we want to have an enum game state probably, and think about what is possible. So basically we want to have a game running, game pause, and game end. So if you, for example, want to go to the options menu, you can pause the game, you can set it back to running, and you can end the game. And if the game has ended, you can't go back to game running, but you have to start a new game, so you can't continue with your old score. Okay, and what we're going to do next is we're going to do the physics handler, PhysicsObject, and we're just going to build in a linked list into the struct, which is basically a pointer to a physics object, which we're going to call next. So basically, what happens is we're going to have a pointer to a physics object, which is called first in our physics handler. This is first, a pointer. This is first. And what's basically going to happen is we're going to go to the pointer to the first physics object. Then we have a game object here, we have an impulse, and we have some friction, and it's pointing us to the next. And then we go to the next game object, and it's the next game object with the next impulse and the next friction, and we can iterate over that. Basically, go through the list like this one points to here, this one points to here, etc. So we've got a linked, because there are links, a linked list. And the nice thing is we can easily add stuff to that. That's going to be a bit more problem is removing from it. But what we're basically going to do is we're going to have a lifetime, for example for projectiles, and we're going to have a lifetime. So basically, when the lifetime hits 0, with each game tick in the game controller, we have a game tick. With each game tick, the lifetime will reduce by 1, and when it hits 0, we're going to remove it. So basically, we're going to the we're basically deleting the game object as soon as the lifetime is 0. So that's the idea how we're going to solve removing. We basically have to remember the item beforehand, because you can't go back. It's not a double linked list. So that would be an argument for using a double linked list. Just so you check an object, check its lifetime, you make sure it's not 0. But if it is 0, you just go back to the list and basically say, okay, you remember the next one, and we leave that out and delete it. But we can make do without a double linked list, I think. So the next thing we're going to do is we're going to do a register with game handler. We're register with physics handler, and what we're going to do is we have a we are having a function which is going to return void, because we don't need anything in return. Well, we could maybe have a bool if we want to have an error state or a feedback if it worked, but it shouldn't really ever not work. I think that's an English sentence. It shouldn't ever not work. So we can go with a void return, and we can say register with, we maybe can call it just register, can't type, and we can now specify what we need. So what do we need is the problem. Okay, most things are created with a static impulse. For example, asteroids. When they are created, they have a static impulse and zero friction. So the only thing that really changes its impulse is a ship, which is either the player ship or the enemy ship. So what we're going to do is we're going to have a GameObject. Don't call it X. We're going to have an object called Geo for GameObject. We're going to have a we're going to have a point I for impulse, and we're going to have a float F for float friction, and that should be about it. So we're just going to take these information, fill them in there, and the pointer stuff gets handled by the logic. So what we're going to do is we're going to I'm not sure what I'm supposed to be getting from this error message. Non-valid memory class for a class member. Maybe it's the problem with the register. Yeah, okay, so looks like register is a keyword we're not allowed to use. So can add that back. I was kind of confused by it. Actually, I don't think I've ever used the register keyword for basically anything. Not even sure what it does. We could Google it, but that's kind of not the point here. So we're now going to implement the RegisterObject. And what we're going to do is we have a lot of arguments. We're just going to copy them over for reasons. And now what we're going to do is we have a bunch of arguments. I'm not sure. Do we? Okay, no we don't. Because, no, right. Okay. Hold on. What we're first going to do is we're going to initialize the pointer first in our constructor. So what we are going to do is first, or maybe this first is null. We're going to make it a null pointer. So by now we need to add an object to our physics handler or show the linked list. We now know that if a first is null, we don't have anything in that list. So what we're going to do is we're going to create a new physics called temp. The standard constructor for PhysicsObject cannot be referenced. It's a deleted function. I'm confused, to say the least. I don't want to. I don't want to call a standard constructor. I just want to initialize my struct. Why can't I do that? Why can't I do that? This is strange. Maybe we need to do it as a pointer. Maybe we need to do it like this. So we're going to make a it's not called node, we called it PhysicsObject. Maybe we need to make a pointer temp and say it's a new PhysicsObject. Yep, deleted function. I'm confused. How would you want me to do? Maybe another. I'm not even sure what the problem is. So I'm going to go back and look at our struct. So we have a typedef struct, which is a PhysicsObject. Maybe the typedef is the problem. I'm not sure. So we're going to remove the typedef. So we're going to say it's a struct. Yeah, so basically that should be fine. So what we're going to do now is we make a struct PhysicsObject called temp. And here it says standard constructor PhysicsObject cannot be referenced is a deleted function. Excuse me. So at this point I'm kind of confused. So let's check the basics. We have included the right header file. Okay? We have a struct which is, as it looks, written correctly. There are no red waves, there's no information for us. And in that struct we have a pointer. So I'll be honest with you, I have no idea. So what do? If we have no idea, we're going to Google it. What we're going to do is auf den Standardkonstruktor von PhysicsObject. Okay, I'm finding topics on C++.NET with the same problem, and it looks like it's a Visual Studio issue because this guy here says he has I just read it. He has G++ 4.8.1 and it compiles without problem. And the guy with Visual Studio 2013 is running into the error. Okay. Okay, what he's going to do is he's going to struct nodes. He's going to struct the vertex. Okay, but that's a problem more complex than ours. They have like a they are overloading some stuff, and we're not doing that. That problem is more complicated than ours. But it's a Visual Studio 2013 issue. I'm using Visual Studio 2015, so that's not going to be the error, is it? I just can't believe that there would be a problem with the software. It has to be me. So, advantages of explicitly default and deleted functions. That's not what we're looking for. Holy shit, I'm going down the rabbit hole with these articles I'm reading. That's not going to help us any further, so let's go back to the basics. We have a struct. Okay, basically we're going to make a struct, a temporary struct, which we're going to fool around with. So we're going to make a struct which is called temp, and we are just going to have a pointer to temp, which is called next. Okay, so all of that fuzzy other stuff we're going to use. It is not in our example, it's a minimal example. So what we're going to do is we're going to try and create a new temp t. And it works. Okay, I'm confused. So what we're going to do is we're going to add, maybe it's a point. What I've included in main, haven't I? I've included point, yep, I have included point, correct spelling. So that's not going to be the problem. So what we're going to do is we're going to add two variables and see if it is a problem. Again, it is not the problem. Yeah, I can use that. So the last two remaining things are a reference to an object, and the GameObject as a class. So what we're going to do first is we're going to create a GameObject, which is called Geo again. Okay, we're just going to point it to Geo. Okay, so if temp works again, yeah, I can use the functions of the GameObject, so it has to be the reference, right? If I'm going to copy the reference over, yeah, that's the problem. So I'm using the reference wrong. I'm not exactly sure what we're doing wrong, but let's just use a pointer maybe and delete that and get back to work. We can go back to the typedef, it's much nicer because it obviously wasn't the problem. Okay. So we now have our physics object, and we have a null pointer. So what we're going to do is we are going to create a physics object called temp, and then we're going to assign temp fraction with f, temp impulse with I, and temp no reference pointer. Okay, so we have a physics object which holds our game object, our impulse, and our friction. And the pointer logic is okay. So basically that's creating our physics object. So if our first is null, then we know our list is empty, right? So we can just set first to temp. Okay, so if our list is empty, the thing we're edging, registering, is the first one. Okay, so that makes sense. And else, we're going to look for the first empty pointer in our list, which basically is accomplished by doing a new pointer to physics object called pointer, and pointer is first. Okay, so it is not null. Okay, so if pointer next is null, which we should do here. So basically, if we added the first one, then this will be null because pointer is first and first next is null. So then we will break, and else we're going to do nothing. So okay, so while true, we're going to do pointer. No, that's here first. So we're iterating over the list. So if the next would be null, we escape the while loop because we have found our last object. If our next is not null, we assign our next to the pointer, and then we start here and check again. So this is our loop iterating over our list until we hit a null, which should happen eventually because we are adding them with a null pointer. Okay, now we have found out that next is null. So what we're going to do is we're going to say pointer is temp. So basically what we're saying is we found the last entity of our linked list, and the next item is the one we're going to add. Simple enough, right? Okay, so we have a list and we can add stuff to it. I'm just looking over things if I forgot something. Should be fine though. We are handling the arguments correctly. We input. We have the special case that our list is empty, and our rest is pretty straightforward. I'm wondering if you couldn't include the first case in this one. Something like while pointer is not null, you iterate over it and you start with basically pointer is first, and then you go like I think that would be much nicer. I think we're going with that one instead. So this is our pointer, and pointer is first. And while pointer is not null, we're doing this one. The problem here is we end up with a pointer which is null, which is not really nice. So we need an additional pointer, which is PhysicsObject last. And basically we're saying last is pointer, and then we're going to iterate pointer. So these two are doing essentially the same. This one looks much nicer, and this one only uses one pointer. So I'm not sure which is like the better solution, but both should work out fine. I like that one better. Looks cleaner. It should basically do the same thing. Okay, next thing, I'm just looking at my list here. Next thing we're going to do is a game controller GameState. I think we already did that. Yeah, we did that. Okay, so my list is empty, but I have a query performance counter. So I'm going to challenge that query performance counter. Okay, I'm reading up on the query performance counter now, which basically looks like it's a that's strange. So okay, we're going to do some private things. What we will do is we have a start performance which is basically initializing our performance counter, and we have a returns a double, um, and we have a few things we need to make. So for the performance counter, we need a PC frequency, which is initialized as 0.0, and I can't spell double. And we need an okay, whatever. I'm not even sure what that does, but that's in the specification. And so what we're going to do is we're going to just create those functions from the specification, which should look like something like that. Okay. Wrong name. Start performance counter. So we need a large integer, which is li. But okay, so that's Windows specific, it looks like. Are we already using something Windows specific? Yeah, we're using the Windows H. So we could just so we have a large integer here. And the next thing we're going to do is we're trying to assign the address of the large integer to the performance frequency. So if not, so if the result is negative of query performance frequency, we're going to have a problem. Because we couldn't query the performance frequency. Excuse me. So, and if it did work out, we now have a large integer which stores the PC frequency. And what we're going to do is we are going to stuff it into our double, which should work out, as I'm reading here, by doing a conversion to double, because it's obviously a typecast, and then going le.quad part, and we're dividing that by 1000, and that should give us the frequency. So what we're going to do, I don't understand that next part, give me a second. Okay, whatever. Query performance counter and li, and then we're going to go counter start is li.quad part. Okay, we used by accident the same method that query performance counter uses, the same name. So we changed that. And the next thing we're going to do is we are going to have a double, because it returns our counter. Get performance counter, and what we're going to do is we're going to have a large integer again, which is called li as well. And we're going to query performance counter with li again. Wait. So now we have a performance counter, which basically gives us the time. If I'm reading the formula correctly, it should give us the time since we last queried it in milliseconds. So basically we're going to start the counter, sleep for a second, I'm going to get performance counter and learn to get 1000. That's the idea. A, sleep is not very accurate, and B, I'm not sure if we're actually going to go that close to the real deal, but it's good enough for our asteroid thing, I think. So okay, that should be enough. So we're going to have start performance counter and then get performance counter, and we can use a delta between two calls and have it run every like 125 milliseconds. So it should be 8 frames, or we can have it run at say 10. Then we should have 100 frames. So we can play around with the number of milliseconds we want to have between calculated frames. So we can do a gametick now. Are we going to do a gametick? We're going to need a run function here, I think, and we will need to register the physics handler, GameObject. No, the physics handler. Going to need to register some stuff, but I'm kind of waving all over the place. So we're at the controller, and if we go back to our graphics, we have the controller influencing the game objects, the model and the view. So our model is just the game objects and the physics. So that should be fine. Okay. Yeah, we need to register the physics, I think, because the physics influence the model. So what we're going to do is we're going to have a private And we're going to have a public something like that. So what I'm doing with the stacking of our implementations is basically everything that's important goes to the top and everything that's not as important goes to the bottom. So it's kind of leaves the window, we have to scroll for it, and everything I really need and it's important should be staying here. I'm sure there's a better solution for that, but it's how I like to set things up. And we have now a physics handler, and we're going to set this. Maybe not. Ah, silly me. Can't copy and paste this. And the physics handler should have a calculate. Well, maybe we should call it run, or maybe we should call it handle, maybe we should call it execute. I'm not sure, but we basically want to have a function that basically goes ahead and checks all movements, does all movements, and then checks all movements for collision, and then removes all objects after lifetime. Or you just call it tick. Okay. And basically every game tick we're going to take the physics through. So we don't need a game tick, basically we need a run function. Void run probably. And what we're going to do is we're going to implement that. And basically what we do is do we have a GameState implemented? No. So we're going to have a GameState state. And we're going to implement that as I can't remember. Okay, game running. So as soon as the game is created, the game's running. And so if while basically while our game is running, we have a We're going to need the delta for this. So this is the point where you need a okay, we have a tick rate per second. So that's simple. So we're going to calculate our delta against the tick rate per second. Basically what we want to do is, if we have 1 tick rate per second, we want delta to be 1000, bigger 1000, right? So if we want to have 1000, we want delta to be 1. I'm struggling with the maths over here. Just give me a second. Tick rate per second by 1000. If we want to have it 1 ps, 1 tick rate per second, then delta would be 1000. If we want to have 10 ps, 10,000, that doesn't work out. Okay, second experiment. If we want to have 1000 ticks per second, 1. If we want to have 10 ticks per second, that would be 100. So that should be the right thing. I don't know why I struggled with that so hard. Okay, then we're going to set delta is get performance counter. That doesn't work. That doesn't work. Because, let's say let's say we have a delta of 10. Okay, really simple experiment. We have a get performance counter that is basically 1000. So since our object was created, we have a 1 second, so it's 1000. So we are setting delta to 1000. And now we have a delta is get performance counter, which is 1020 minus delta, which is 1000. So we have 20 in there. Delta is bigger than the tick rate. Maybe yes, maybe no. Doesn't really. There's not really defined circumstance. It's always yes or always no. So it depends. If we think it's no, then delta, which is 20, is get performance counter, which is, let's say, 2000 minus 20, which is 1800, which is not true. Our delta is not 1800. So that makes no sense. That here is wrong. That makes no sense at all. And so that's probably does this as well. So what we're going to do is be clueless. So what we want to achieve, we want to have a delta growing until we set delta to 0 again. So what we need is we need a last, right? So we don't need to define delta, we need to define a last, bool last. And last is, so we have a performance counter, and we're going to set a new delta. So we're going to do this. Bool, no bool, double delta is a so now we have a real delta. We have the current one, which is probably higher than the last one, hopefully. At least we have a decent chance of it being. And if delta is bigger than this one, we're setting last to the current one. And if we don't do it. So our delta grows. Because our last stays the same while the get performance counter rises, so delta's getting bigger. And as soon as we calculate, we're going to assign a new last. That's the right calculation. So, and what we're going to do here is do a physics handler tick. I thought there was a red dotted line, but I'm just blind. Nothing there. So every time we hit a thing, our physics handler ticks through one time. And the player actions will be asynchronous. We don't want the player action to be delayed. So we're not doing them with a physics handler, we're going to do them directly. And for that purpose, we're going to need a direct link to the ship object, which we can then turn with the user input. But as we don't have a class for our ship object yet, we'll need to create that, and then we're going to register it with the game controller and turn it around. So the next thing would be to create a class for the. I'm just going to write it down here. Create class for player ship. Register the player ship with game controller, and then we're going to do a user input, and then we're going to do render player ship. So then we're going to create a ship by using our GameObject. Then we're going to create the player ship with the game controller, register them. The user input is already defined in our main, but we need to extract it to the game controller. Then we're going to render it using the vertices here. We need to rotate it, so that's going to be interesting. So we basically need a to view method for our ship, because our points change, but we can use Pythagoras for that. And then we're going to render it, and then we're going to then we're going to use the game board, and then we're going to move the player ship. Then we're going to create a class for the asteroids. Then we're going to create a projectile with lifetime. Then we're going to implement collision, probably. Collision should be useful. And then we're going to the asteroids destroying thing, so we're spawning baby asteroids after you destroy the mother one. That was grim, actually. And then we're going to handle additional stuff like text, lives, points, high score, everything else basically. So that's our to-do for the next parts. I'm not going to do that in one part. That will be our to-do for the next parts, and that's basically all we need for a functional prototype. And then we can fine-tune it, check how many ticks we really want to run it at. Basically initialize the tick rate in the that one is a don't know, 21 maybe. We can play with that, see how it plays fluently and adjust accordingly. Yeah, I think that's a pretty good roadmap. Just text one, nothing fancy. But I really like what we have so far in the roadmap. I'm not too proud of the physics handler struct PhysicsObject misbehaving. I'm still not sure what's up with the reference, but I somehow messed something up, didn't understand it completely. So I'll be studying that, see why the PhysicsObject reference kind of screwed us over and we have to use a pointer. Yeah, this is good. I like it. Very structured approach to this project. Usually not my type of programming, but I'm backtracking a lot. Maybe you realized I was backtracking a lot, like, oh, I forgot this here, and I forgot this in another file, and oh, this one needs to go here, and we're just going to add that there, and yeah, that's like more of my programming work, which I really need to work on. It's not really the best case scenario. But this will be it for this time. I hope you had some fun figuring things out with me. Maybe you were faster than me, especially with the math. I really regret that. Like, such an obvious solution, and I kinda got stuck on brain farts. Yeah, this one really cost me. But I still hope this is interesting for somebody, and I mainly do this for documentation purposes, like so I can go back and show what I've done and what I thought, and maybe I can improve on myself by watching myself do this. And I hope everyone that comes across this tutorial at least gains something from it. If not, I'm sorry. Thanks for watching anyways, so much actually. I'll see you in the next part. Take care.